Okay, inverses of matrices. Now, if I have the equation 3x equals 9, most of you would solve that by doing what? Yeah, dividing by 3. Now, and of course we would find out, okay, x is 3. Well, what is 3 to the negative 1 power? What is a negative exponent? No, it's not negative 3.
Is it not?
Put it in your calculator. What is 3 to the negative 1 power?
Is there an error?
No, no error.
It's 0.33.
0.33 repeating, which as a fraction is 1/3. Okay, so another way we could do basically the same thing would be writing this as multiplying by 3 to the negative 1. You still get 3 for a final answer. That is the process we need to do to solve a matrix. Okay, we have to multiply by the inverse of the matrix. So if we multiply this and the other side, so if we multiply both sides, so we would have a to the negative 1 times a times x equals a to the negative 1 times c. And those are matrices, and the matrices cancel out. Okay? So it's a very similar step, but we also know, and I know you're freaking out right now, it's something new. It's not. So what we have, if we know matrix A and matrix C, we can find the unknown, because what we can multiply, again, what we do, I guess I wrote that down, we will multiply by the inverse of the matrix. And order of multiplication matters. So if we do those steps, those two matrices cancel out each other the same way that dividing by 3 does, the same way that 3 to the negative 1 does. Yes? Well, what is the step to get rid of it is multiplying by the inverse. We multiply by the inverse. It's not the same thing. It's a to the negative 1. Yes. Correct. Yes. Okay, now, what you got to be careful with this, guys. Matrix, multiplication, things have to match up. So you can't do this. If you do this, C, matrix C times a to the minus 1, you're going to get a dimension mismatch. Right? You're going to get that dimension error if you don't have the right size dimensions. No, we're not pulling it out of nowhere. Okay, now we started out with, how would we solve this equation? We could divide by 3. Okay, right? 3 times x equals 9. What is the inverse of multiplication? It's division. What's the inverse of addition and subtraction? So the inverse of a matrix is still matrix multiplication, but we have to multiply by the inverse. So that another way, and this would be a weird way to do the same step, because the negative exponent moves into the denominator. 3 to the negative 1 is 1 over 3. Negative 1 exponent, that's identifying this, the inverse of the matrix.
So it cancels out the A on the X side and you just leave it on the other side.
Correct. Correct. Okay? Now, so what you have to do, you have to be able to find the inverse. Well, it's pretty easy. There is a formula to find the inverse of a 2 by 2 matrix. And it's kind of a complicated formula. It's really easy to do this on the calculator. We're going to do one, so you really appreciate the calculator. The formula for this is 1 over AD minus BC. And then that has to be distributed to D and A switch places. And B and C switch places. Do they switch places? No, they're just negatives. I'm going to double check that equation, that formula, because I don't have this memorized. Because you only teach this, even in Algebra 2 class, you only look at the formula once a year. Yep, that's right. So the B and the C have to be negatives, or opposite signs, and the A and the D elements switch places. So to find the inverse manually without a calculator, I would just have to follow that formula. So let's see, it would be 1 over AD, so that's 2 times negative 8, minus BC, which would be, what is that? BC is 8 times negative 1. And I would need to multiply that by, let's see, D and A switch places. So D and A, that would be negative 8, A is 2. And then 8, the B and the C stay in the same place, but they flip signs. So then that would be a positive 1 and a negative 8 down here.
It's easier this way than what before.
I mean, it's just hard.
Well, this is your second time doing this, right? It's always easier the second time.
He has a point, Ross.
It's true. I say
I
this.
don't think you not get much of the test. So,
Okay.
It seems.
It is.
It's just plugging in numbers.
So then, what is this? 2 times negative 8, that's 1 over negative 16 plus 8.
Why is it plus?
Minus 8 times negative 1. So that's 1 over negative 8. Times negative 8, negative 8, 1, 2. So then if we distribute that, let's see, what do we get? We get 1/8, negative 1/8 times negative 8, that would be positive 1. Positive 1 there. Negative 1/8 there. And what? Negative 2/8, which would be negative 1/4 there. So that would be the inverse. That would be, this question here asked me just to find the inverse.
Is there more than that?
Yes,
It's just doing this.
we're just doing this. We're going to take time. We're taking our time to make sure we process and understand what's going on. Now, let's get our calculator out. Okay, now, if we, let's go ahead and go into my matrix menu, and let's put that inverse in the calculator. Let's put the original matrix in there.
How did you just get there, though?
Second x to the minus 1 is matrix. And we're going to edit matrix A is what size? 2 by 2. So we've got 2, -1, 8, -8. And let's find that inverse. Matrix B. Matrix B, 2 by 2. Oh, I did 22. That'd be a big matrix. And that's 1, -1/8.
Are you putting in the inverse right now?
Yeah, I'm putting in the inverse now. So there's matrix A, there's the inverse, matrix B. So what now? Let's take, wrong button. Let's take matrix B times matrix A. I hit the wrong button.
Why is it B times A and not A times B?
Order, well, this one order wouldn't matter, but if we're solving an equation, order matters.
Wait, how did you put in that? I don't understand.
I hit matrix and now use the name on the home screen. Now, yeah. So this is why this gets useful. Why is this useful? What do we get? Yeah, then you have something incorrect if you got invalid dimensions. Now, when you multiply that out, what did you get?
1, 0, 1.
Yes, we got 1, 0, 0, 1. That's the identity matrix because we got ones. Because what this is going to allow us to do is solve an equation. You're not okay with this.
Wait, why did you write this down?
So you got dimension mismatch, and you didn't do something right. No, it shouldn't be. Yeah, you got it. You were fine. Okay, so when you multiply, yes, Katie. Okay, well, what do we do? I follow this formula. Okay, so this is what happens. A, B, C, D are the 4 elements of matrix A. To get the inverse, A and D switch places. Get B and C flip signs. And then you have to multiply it by AD minus BC. Okay, so we just followed that formula. Okay, so, ladies and gentlemen, where this is useful is this gives us the identity matrix. So if this is a equation or a system of equations, this is going to allow me to find the answers. Now, if we just want to find the inverse, okay, if I go second matrix, since we already have it in there, A to the minus 1, and notice that x to the minus 1, there is a reason that those buttons are the same button. Okay? Somebody was kind of smart when they developed this. So there we go. There's my inverse matrix without doing any work other than typing stuff in the calculator. So that's going to help.
Oh, wait, that doesn't.
Okay, now if you want to have the fraction there, we can always go math fraction, and we can get the exact fractions if we don't want to have rounding errors.
I don't like fractions.
I know you don't, but the calculator can handle them. Okay, so just for the practice, but understand where we're going to use this is to solve an equation. That's on the back side of the notes. No, all we did is find an inverse. So for the practice, let's find the inverse of this other matrix here. So I'm going to go back to my matrix menu. I'm going to edit matrix A. It's a 2 by 2 matrix. 0, -2, -3, and -12. Now, it is possible that a matrix is not invertible. So that can happen. And then if that's the case, then there will be no solution. Okay, but if I modify that matrix just to get the inverse, what do I do? Home screen, matrix A, x to the -1. There's A inverse. So getting the inverse on your calculator should be really easy. And I've been telling you all this time, because we do not have to want to do this all the time.
Do we have to do that eventually?
No, we're not gonna do that invert. Just appreciate that the calculator will do it for you. What we have to understand, the whole point of this is going to be more important to understand what we're doing on the back side of the notes page, which we haven't got to yet. So what? Oh, now what?
Yay!
Yes. Hopefully the board is broken.
Oh.
No, but I can't get my calculator back up. All right, did all you get the same answer on the calculator for number 2?
Can we try just like the 3 as a leading? Is that okay?
Huh?
The -0.3.
Yeah, you could do that, -0.33. Okay. Now, here's the whole point of this. Wait a second, is that the one we just did? No, it's not the same one. Okay, the whole point of this is this allows us to solve a matrix equation. Yes, we're going to solve for the missing matrix. So what will we need to do? Correct. And the order matters. I'm going to come back up front. So what will we need to do? We need to get, okay, we will multiply to get x. We need the inverse of this matrix multiplied by -1832. Now, order matters on this. Okay, so you need to get the inverse of that matrix. So you could actually set up your matrix A and your matrix B. You wouldn't even have to find the inverse, you just have to set it up and multiply it out.
You made it stop being
Yes, I made it stop being B.
You just swear to you. You just swear in most words.
Maybe that's so fun. Very stupid. the negative one element?
So how would we enter?
How would we enter it? Well, enter this first one. Whoops, I pressed the wrong button. We want to go across to edit.
So you just do matrix A and then you hit negative 1.
So first of all, you could find the inverse, but you could just write, if you want to, you could find it and write it down, but it's also perfectly acceptable to write down the steps just as I did. Okay, so then we got 0, -3, 2, 4. So there's my matrix, 0, -3, 2, 4. That's my matrix A. And I'm going to go back to my matrix menu. And edit B. And B will be 2 by 1 now. Yeah, because B is -18. 32. And we got a to the -1 times B.
Is it 4 and 6?
Yep, 4, 6 is the answer.
I'm understanding.
You're understanding that?
I did it.
So it is a matrix equation. What was the answer? 4, 6. It's a matrix equation.
Wait,
Only they were all easy.
why do we need to find X? Wait, have we not found X yet?
Yes, we have.
No, we have. I'm just saying, why do we need to, what are we using X for? Why is that?
X is a matrix.
Everyone asks what's X. We don't ask why is X.
X is a matrix. This is a matrix equation. So we had this times X is equal to -1832. So in order to, again, it's like, that's why I kind of showed the weird fraction way of writing dividing by 3. It's a similar step, but it's with a matrix. We have to do the inverse.
On to the next.
On to the next one.
4 and 5 is just the same practice. Let's talk about. We need to talk about 6 and 7 because we're actually getting to the end of the lesson here as it is.
6 and 7.
We have time. You can do 4 and 5 for practice.
See, we were climbing the mountain, and now we tripped, fell.
No.
Rock, and we're tumbling back down.
Okay. So what we have here. So and really what we have, even with doing these problems here, we're able to solve a system of equations. And we did systems of 2 equations, 2 unknowns. We actually could do that with 3. 3 equations, 3 unknowns, or 4 equations, 4 unknowns. That would be a lot of work to do elimination or substitution.
Oh, we're
A
just
lot of
like
work.
that? That's
So what we do is we want to rewrite this, what we have, these whole steps. We have a coefficient matrix, we have a variable matrix, and we have the constant. So what we do is we put all of our equations into standard form, and the answer will be A inverse times C, which that is exactly the way we did number 3. We just didn't call it that yet. We were just going through this to see. This is basically matrix A. This is matrix X, right? And this is matrix C. Okay? So if this was a system of equations, okay, then this would be the X, this would be the Y.
Oh, that makes sense.
Okay? That could be any variables.
Wait, I'm writing that down.
Writing this down? Okay, give you a moment. So this allows us an easier way to solve 3 variables. And it's easier than substitution and elimination. It's all calculator punches, but you just can't have a typo on your calculator.
What were we supposed to do about the variables?
Okay, we'll talk about it.
Wait.
Some people are still writing, so I'll wait till you have that copied down. Okay, now we're good? Okay. All right, so what are we going to rewrite? We would have a constant matrix. So what is my constant matrix? My constant matrix, my matrix A. Now, first of all, we got to have all our equations in ascending order. So I got RST, RS, no T, RST, and they're all equal to a constant. So this would be 1, -5, -4. Now what is that? I took my coefficients of my variables, RST. So my next equation would be 1R, 4S, 0Z.
Very cool, Matrices.
So basically, you're plugging in the numbers.
We're taking the numbers of the coefficients, yes. Now this only works if they're linear equations. If they're non-linear, if we got squares or fractions, variables or in fractions, then you have to do substitution or graphing.
Are we gonna solve for R?
We're going to solve for R. Ultimately, we're going to solve for RST.
Oh.
So what is my third equation? 3, 1, 4.
Oh, okay.
What is my variable matrix? My variable matrix is RST. Because now, understand, what is this? If I multiply, what do I multiply? I multiply a row times a column, right? When I multiply. So that's 1R minus 5S minus 4T. Second row, 1R minus 4S minus 0T. Third row, 3R plus 1S plus 4T. It's just matrix multiplication. This is going to be the same equation written as a matrix. What's the answer? The answer, we have, this is our variable matrix, so this is our X matrix, our matrix C. And what is A? A is 3 rows by 3 columns. Matrix X is 3 rows by 1 column. So my answer will be matrix C, 3 by 1. 3 rows by 1 column. So matrix C is the constants then, which is 5, -3, -17.
Oh, okay.
Okay, so what's the answer? The answer RST is my variable matrix. I need to do matrix A, which will be, I need to do A inverse.
Oh.
I need to do the inverse of this, which would be 1, -5, -4. Same step we did above. 1, 5, 1, 4, 0. Whoops. 1, 4, 0. And I need to do the inverse of this. 3, 1, 4. Multiplied by my matrix C. 5, -3, -17.
When you put that in the calculator.
So we went from the equation and we multiply by the inverse.
Is it only the inverse of A? Or is it the inverse of C?
No, only the inverse of A. And if just to follow things since we're using sometimes A's, B's, and C's, I'm gonna put it into C just to use the same. So matrix A, I'm gonna go 3 by 3. One, -5, -4. 1, 4, 0, and then 3, 1, 4. So we got to enter our matrix A.
And then is it gonna be A times B?
B or C. I'm gonna go ahead and use matrix C just to keep the same with the notation for the way the formula is written.
Okay.
Matrix C is what, 3 by 1?
Is it 88, 97?
So what do we get? 5, -3, -17. And then back on the home screen, we got to do A inverse. Did you remember to do the inverse? A inverse C.
Negative 302.
-302.
I do not have enough room to do the second.
You don't have enough room to do the second one. So, yes, you're my only regular officer too. All my other classes are project away. Okay, so what does that represent? What does that represent, guys?
I don't know.
R is -3, S is 0, and T is 2.
Cool. Learning.
Now, is that easier than doing elimination or substitution with 3 variables though? Yes.
Yes, it is.
That was so much. I would rather do it.
With 3 variables,
Okay.
it would take a long time. We would take a half sheet of paper to do elimination with 3 variables.
I'd rather do none. Is the manual way that we did elimination?
What's that?
Is the first way we did elimination?
That was before on our last quiz. We didn't even do 3 variable
Yes,
elimination.
elimination was like,
That's where you add the equations and see what cancels.
that's easy. I can do it.
All right, do right now.
This is easier.
It was just taking me a second.
Now, big thing is, guys, what do you have to have? You have to have standard form. Okay, so on these equations, we do not have standard form. We have to reorganize some of our variables. So my second equation, I would need to subtract the 7y.
I said,
So my first equation is okay, right? 4x minus 2z equals 20.
Oh, yeah.
My second equation, I would need to subtract the 7y and have a -7y plus z equals -9. And my third equation, I need to move both of these over. X minus 5y plus 8z. Oh, minus 8z. You guys missed a piece of candy. Minus 8z equals 15.
why is it minus?
Because I have to move them to the other side.
Oh.
You have to put them in standard form.
Trust the process.
Process of truth.
So what would be my matrices to set up? Matrix A is what?
That's very interesting.
4,
Or -2.
4, 0, -2. There's no y.
Okay.
Second row. What's the second row?
-7.
0x, -7y, 1z.
Okay.
Third row.
One, -5.
1, -5, -8. My variable matrix would be x, y, z. My constant matrix would be 20, -9, 15. And at that point, I'm going to set this up as matrix C, A inverse C, and I get my answer.
I think this makes sense. So you just for A, you used X, Y, and Z in each of the equations, and then you plugged it. Did you plug it in by row or column? Like.
I went by rows.
Like it's, okay, so it's like.
No, always go by rows, because the
So-
row is the equation.
So 4, 0, -2 are all the X values?
No,
What?
4, 0, -2 is the first equation. 4x, 0y, -2z. The second equation, we had to move some things around, but the second equation is 0, 0x, -7y, 1z,
Does it go like X, Y, Z?
x, y, z.
Okay.
You have to put them in standard form first. Okay, so I know that was a lot of notes and getting through, we didn't even do all the examples. That's okay. We'll have the next few days to practice this. We need to go over more, we'll get there.
Oh,
We can vibe with this for now.
that is.
Discombobulation.
Yeah. I'm sure, and then we see Ron Woodward, who left me on red.
All right.
I still work through tonight,
On
and I feel like I'm doing nothing, so it's great.
I
I'm over at home.
At that point, she worked